Okay, hi everyone. So in this example, we're actually going to look at a relation here where we actually have velocity versus displacement. And in some occasions in the questions, they're going to ask you to derive the graph for the relation between, for example, in this case, acceleration versus displacement, or it could be maybe acceleration versus time. But let's look at this example of acceleration versus displacement that we need to convert this velocity versus displacement graph. Okay, you work from the basic understanding of the concept of acceleration and velocity. So what we know is that acceleration is actually equals to the rate of change of velocity, so dv per dt. And we know that velocity is the rate of change of displacement, which is going to be ds per dt. And we can actually rearrange the formulas, right, to get a relation between the parameters. So in this case, right, what we want to do is get a relation between acceleration, displacement, and velocity, and ignoring the time variable. So based on these two expressions, when I do the multiplication of a times 1 over v, what I'm actually doing is I'm actually doing dv per dt multiplied by dt per ds. That's 1 over v. So what I have is it then becomes dv per ds. Okay, so I have established a relation where acceleration equals to v dv per ds. Okay, when establishing, for example, in this case, we are needing to find acceleration versus displacement. We could rewrite this formula to be a ds equals to v dv. And we may use integration to find the relation. But unfortunately, we are not given the relation of acceleration as a function of s. Okay, so in this case, right, the better formula, right, for this situation is to use this function here. Okay, so what we need to do is actually just find the rate of change of velocity with relation to the displacement, which is actually given on the graph here. Okay, so based on it, let me look at it. So there are two ranges of our graph. So one that is from 0 to 3 meters and another one that's from 3 to 6 meters. Okay, so let's look at the range from 0 to 3 meters. Okay, so what happens is we have a equals to v dv per ds, which would make it equals to v. Okay, I can substitute v as the function for the first range of 0 to 3 as 2s plus 4. Okay, same goes with the differential inside there. I will actually differentiate this 2s plus 4 with reference to s parameter. So what remains is 2s plus 4 times 2. Okay, so in order for us to get some information, so you can actually see that if I were to write a here, so a is based on this relation is going to be a linear function. So a will be equals to 4s plus 8. Okay, 4 being the gradient of the graph and then 8 being the intersection at the y-axis, or in this case is the a-axis. But since we have some information about where the s values are, so we actually had starting point s equals to 0 and also s equals to 3. So let us find the a values at those situations for the first range of 0 to 3 meters. So at s equals to 0, we have a equals to 8 meters per second. And at s equals to 3, we have a equals to, so 3 times 2, 6 plus 4, that makes it 10. So this would be 20 meters per second. So we do the same for the range between 3 to 6 meters. Okay. So what happens is we have a equals to dv v dv per ds. So equals to s plus 7 times d s plus 7 per ds. Okay, that would actually leave us with s plus 7. Okay, so again we actually find out the values for acceleration at those points of 3 and 6 meters. So at s equals to 3 meters, okay, we have the acceleration value at 10 meters per second, while at s equals to 6 meters, we actually have the acceleration at 13 meters per second. So if we were to plot the graph, so the acceleration versus the displacement. Okay, so from 0 to 3 meters, what happens is we actually have a at 8, and then it goes up to a maximum of 20, and it's a linear graph. So we actually have a line that goes from 8 to 20 like this. And for the second range of 3 to 6 meters, we actually have a at 10. So starting point at 10, and then it goes up to 13 meters per second, so something like this. Okay. Alright. Okay, so that would be the relation of your A versus S graph.